In case you guys have any gaps later after the class, you can always go back and actually rewatch the lesson. And we will share this on our YouTube channel as unlisted, so no one else will see it other than those with the link. So, and we'll only send the link to you guys, okay? So yeah, Alex started the recording. Let me take the attendance really quickly. So
I just done. I think everybody's in.
Yep. So you've done the attendance?
Yeah, I went through the signing sheet.
Good. Sounds great. Okay, so we're set to go.
Yeah. All right. So the way we're going to be doing it, I will be sharing screen with instructions. If you guys already gone through our Zoom classes, you're pretty much familiar with the concept. If you guys will at some point require help with your code, there is a way to share your screen, and you will be able to show it to the entire class or just to the instructor. Also, if you're experiencing any difficulties, we have 3 instructors today, and there's a such feature in Zoom that breakout rooms. So for example, if you would like some one-on-one help and we don't want to slow down the class, we can set up a breakout room, assign you and another instructor to it, and you will be, he'll help you to figure it out in a one-on-one session without delaying the rest of the class. Ayan, you have a question?
Yeah, is it C# code?
Yeah, actually, yes. Yeah, it's very similar. Yeah. So yeah, so you guys see my screen, right? So yeah, I wanted to just quickly go over what Arduino is and what is it used for. So Arduino is a development platform. It's a universal development platform, and it's been used for creating prototype devices, smart toys, drones, aircrafts, home automation, and things like that. The stuff that you have in your box is sufficient to make a lot of really cool projects. And this week, we'll be spending every day building 1, maybe 2 per day if we have, if we go fast enough. Okay, so we will be covering how to connect those sensors, how to read information from sensors, and how to program it. So few things that, you know, just inspirational to see what is possible to do with Arduino. Like for example, this super cool robotic drummer is something that can be done using Arduino for controller. Oh, well.
Tim, can you show your current project that you're working on?
Yeah, and Tim will show his as well. This is another thing that is. Oops.
Oh, I can't see it.
Tim, you have your
the background. Yeah.
Background merging. Does your robot dog already operate? Do you have batteries on it?
No, the motor is still weird, but basically here is a robot that can like walk around very nicely.
It's kind of fusing, Tim, with your
it is kind of fusing.
Background replacement.
Maybe remove yourself and the chair and just show that. Maybe that'll.
No, the Zoom will not recognize this thing as an object.
Yeah, Zoom does like human detection.
Zoom has AI to find the.
Yeah.
Anyway, I'll send some pictures later.
Yeah, that's pretty cool.
Yeah, I have a video on my phone. I will share it afterwards.
Mm-hmm.
Yeah, this is another cool thing. Is just a bicyclist robot that uses Arduino and some gyroscopes to keep the balance.
And Alex, remember that Halloween thing with GarageBand that you guys did? Did you use Arduino for that? Yeah, actually, we used the RoboRio for that to control it, but you can do Arduino as well. We needed wireless functionality. That's why we couldn't do Arduino because what we have in our kits is a basic kit, so you don't have wireless capability on it. It's on the YouTube channel, so if you want to show it later.
Yeah, but there are Arduino platforms that have Bluetooth and Wi-Fi on them as well, so you can make them into a smart device that you can access from anywhere in the world with your phone. So what the Arduino is? Arduino is basically a microcontroller. This part is in the heart of it, and it also has a gazillion of compatible sensors that can do anything, measure distance, sound, temperatures, motion, humidity, illumination, vibration, things like that. And the problem with that is that you will find it very hard to connect all those sensors directly to the microcontroller, because you see that it has only pins, and without much of a description of what each of the pins is doing. That's why a group of Italian engineers came up with the Arduino circuit that now is a huge variety of available on the market. And the one what we'll be working with is Arduino Uno, this guy. But also there's a Mega that has way more different pins, outputs, and inputs. There are lily pads, and it's kind of symmetrical thing that you can use in the wearables, or you can use in flight controllers for drones, for example. There are Bluetooth options. There's a Nano that you can use in smart watches and things like that. The stuff that we will be covering is this guy. The heart of it is that Mega microcontroller, and so that you wouldn't have difficulty connecting sensors to it, it is placed on a very convenient board that has a power input so that you can power it up. It has USB ports for programming, so it has a programming interface to the chip, because without this thing, it will be also very difficult to program the microcontroller. But with this thing, all you need to do is plug it in your computer, and you can push a code. The Arduino also have a variety of different pins that are very easy to work with. You basically plug your wire into those connectors, and yeah, that's how your connection between sensor and Arduino is done. And we will cover what kind of pins there are. There are pins that are digital, and there are pins that are analog, and I will explain the difference between them. And there's also like a dedicated section that is a power supply, so it creates a means to power our accessories, whatever you want to connect to your Arduino. So in order for us to visualize, simulate, and test our circuits, we will be using the Tinkercad. And this is how you go in. So it's browser-based. So you need to go to tinkercad.com. I will provide you with the login instructions. At the moment, you don't have to do it, but I will show you how we will quickly prototype the circuit, talk what the circuit is, and how to test it. So I will create a new circuit. It will automatically give me a really funny name. So my circuit name is Shani Firan Denzer. So I don't know what that means, but Tinkercad automatically assigns those funky names to whatever you start. And on the right side here, you have all the components. This is a basic set, and you can go to advanced set or all. And in this case, you get a much wider variety of things. You get like transistors, different microchips, relays, and things like that. We'll stick to basic for now. So basic is basically all the stuff that most of the stuff we have in our box that we're going to be using. So main part is bringing Arduino to our workspace. You can rotate it using those icon here with the two triangles and an arrow. Let me try to rotate it so that this thing, all the inscriptions here in there, convenient to read orientation. So right now, if I would like to create a circuit, I will need to bring something that's going to do some work for us. For example, LED. I'll bring LED. I will connect the wire from ground to one leg, and I will connect a power source, 5 volts, and I will tie up the wires like this, and we got a circuit. So circuit, one of the properties of the circuit that it has to be closed loop. Open circuits don't work. Electrical current tends to flow from a power outlet through the consumer device and back to the ground. It's like a garden hose, except the tip of that hose is not open. It's connected back to the pipe, and the water is circulating. In here, instead of the water, we got electrical current circulated. So if you connect LED like this, most likely LED is going to burn out because the power coming out of Arduino is quite substantial for the small consumer like this. But if you connect a motor, for example, DC motor here, and I'll delete this guy and I connect motor here, and you guys have electric motor in your kits, which is super handy, and you connect it like this, you're going to have your rotation. So if I start simulation right now, you can see that my motor is spinning. Okay, so Arduino, once you plug it into your computer, is capable to generate electricity as a power supply, and that would be either 3.3 volts or 5 volts. What do you guys think? Is the 5 volts a lot or a little?
Not that much.
Not that much. Okay, well, comparing to the outlet that you have in your wall, it's indeed not that much, because your outlet has 110 volts. So when you plug in your stereo or your table lamp or any kitchen appliance, it's going to receive 110 volts out of the outlet. But if you look at the a small battery, that like a round finger battery, double A, it's only 1.5 volts. So Arduino actually delivering 3 times as much as one single battery, but 20 times less than outlet in the wall. Also, Arduino is being powered by USB, so when you plug it into your computer, depending on what kind of computer you get, you sometimes get a juicier source of energy, so you can connect more than motor and LEDs to your Arduino. And sometimes if you have small device like an Ultrabook and that is running off the battery, you might get not that much of an energy there. So as soon as you start overloading your Arduino, you might experience connection issues. Okay, so okay, let's now try to see what we can do if we want to connect something else together. So I have motor is already connected, so I want to connect this this LED as well. So let's try. I will connect ground to my short leg, and my plus. I don't really have any other place I can connect it, because the only 5-volt pin is already used.
3.3V.
You can connect to 3.3, okay, but what happens if we have something else? If we have another LED and I want to have it green, and I can connect it to the last remaining ground, and my other leg is again stuck. You don't have anything else to connect it to. Oh, what do we do? And sometimes your gadget that you're going to be building will require more than one sensor to be connected to. You, for example, make a security system and you want to use something fancy like motion detector, ultrasonic. There you go. So now our ultrasonic is here, but we don't have any more power supply pins. We only have 5 volt, which is only one. So what do we do in this situation? Well, in this case, there is a very handy contraption existing that is also part of your kit, and that guy is called a breadboard. That's it. This is the breadboard. Let me also rotate it. Let's get that motor out of the way. Here's our breadboard. So in this case here, if we to, for example, use the breadboard for connecting our sensors, what we can do is we can connect plus 5 volts to the plus bus here, and the ground to the minus. Now we have all this line here is your power supply. So if you want to connect 25 LEDs, you don't have any problem. And if you want to connect 10 different sensors, you don't have problem either, because now you have all those pins here working together as a ground. Also, as a side topic, once we add it, it's better to actually change color of the wires to something that designates power. So I'm going to use this one for red, so that you can tell right away that this is a power line, and the negative we can keep green. It will show you as the ground wire. So I would like to show you a quick video here of how to work with a breadboard and why is it called breadboard. Here it is. And I'll share the sound as well.
In this video is an introduction to how to use a breadboard. This is a breadboard. It's a rectangular piece of plastic with a grid of holes that allows you to easily and quickly build electronic circuits by pushing electronic components into the holes. For example, simple circuits like this one with a battery and an on-off switch to control a light. You can also build more complicated circuits, for example, lights that flash automatically, or robots of all different shapes and sizes. There are far more examples than we can list in the beginning of this short video. At this point, you might be thinking that this doesn't really look like it has anything to do with bread. The name breadboard comes from the early days of electronic circuits when people would literally use wooden boards with screws or nails driven into them to make electronic connections. Modern breadboards are made from plastic and come in all shapes, sizes, and even different colors. The most common sizes you'll probably see are full-size breadboards, half-size breadboards, and mini breadboards. Larger and smaller sizes are available, and many breadboards come with tabs and notches on the side that allow you to snap 2 or more of them together, but a single breadboard will be more than sufficient for most beginner projects. Let's take a closer look at how a breadboard actually works. The holes of a breadboard allow you to easily push the leads or metal legs of a component like this LED into them and then will lightly hold them in place. This connection is strong enough that the LED won't fall out on its own, but light enough that if you make a mistake, you can easily pull it out and put it in a new location. Technically, these are called solderless breadboards because they can make these connections without using solder or melted metal to permanently bond electronic components together. Let's find out how breadboards can hold on to components without using solder. If you flip a breadboard over, they come with an adhesive backing that allows you to permanently stick them onto a project, for example, the breadboard stuck to this robot. If you remove that backing completely, like I've done with this breadboard here, you expose a series of metal strips that are inside the breadboard. These metal strips are what make mechanical and electrical connections to the components you insert into the breadboard. We can remove one of these metal strips by pushing it out from the front to see what it looks like up close. Each strip is a series of 5 clips that line up with the holes on the breadboard. When you push a component into the breadboard, these clips are what's actually grabbing onto the leads, like you can see here with this LED. This breadboard is actually made from transparent plastic, so you can see the clips from the outside. When you press a lead into one of the holes, it's just getting grabbed onto by one of these clips. Let's take a closer look at the writing on the front of your breadboard. Your breadboard has columns labeled from A through J, and rows that start with 1 and go up to a number that depends on the size of the breadboard. These labels make it easy to follow directions when building a circuit. For example, all of these holes are in column C, and all of these holes are in row 12. Hole C12 is where column C intersects row 12. There are also long strips on either side of your breadboard that are usually labeled with red and black or red and blue lines and also a plus or minus sign. These are called either buses or rails and are used to deliver power to your entire circuit. Typically, the red one marked with a plus sign will connect to the positive battery terminal, and the black or blue one marked with a minus sign will connect to a negative battery terminal. Some breadboards, like this mini one, do not have power buses at all. Some full-size breadboards have power buses that run the entire length of the breadboard, as indicated by the continuous unbroken red and black lines. Other ones have power buses that only run half the length of the breadboard, as indicated by the break in the lines here. This is convenient if you have a circuit that needs to be powered by 2 different voltage levels. In order to use a breadboard, it really helps to understand how all the holes are connected. Let's take a look at hole A1 as an example. Remember that inside the breadboard are sets of 5 metal clips. This means that hole A1 is electrically connected to hole B1, hole C1, D1, and E1. It is not connected to hole A2 because that hole is in a different row and they do not share the same set of metal clips. It is also not connected to any of the holes on the other side of the gap in the middle of the breadboard. That's holes F1, G1, H1, I1, and J1. We'll explain more about what this gap means in a little bit. This diagram shows all of the connections on the breadboard highlighted with yellow lines. Each set of 5 holes forming half a row, that's those on the left in columns A through E, and those on the right in columns F through J, is electrically connected. The power buses run vertically on the sides of the breadboard and are typically connected over more than 5 holes, although this can vary from breadboard to breadboard. The individual power buses are not connected to each other. Let's take a look at what all this means for a common demonstration circuit with a battery, a resistor, and an LED. When I turn the battery pack on, the LED lights up. Pretty simple. Now let's zoom in and see how I actually have everything connected on the breadboard. The battery pack's red lead is connected to the power bus on the right side of the breadboard. This is connected to a jumper wire that goes to row 5, which then goes to the LED, over to row 5 on the other side, to a resistor, to the ground bus, and then to the battery pack's black lead. This diagram shows how electricity flows through the circuit using yellow arrows. This is called a closed circuit, or a complete path for electricity to flow. Remember that on each separate half of the breadboard, the holes in row 5 are electrically connected to each other. This means, for example, that I can take the leads of the LED and move them to different holes in row 5 and it will still light up. However, if I take the LED and move it to a different row entirely, like row 4 or row 6, it does not light up because there is no path for the electricity to flow. It has to be in row 5 to have that complete path. You can also reconfigure the entire circuit. For example, here I'm going to move the LED and the resistor over to the right side of the breadboard, and then connect the battery pack's negative lead to the ground bus on this side. While this looks different, electrically it is the same circuit, so the LED still lights up. You can see that in this diagram by tracing the yellow arrows, and noticing that there is still a closed path for the electricity to flow through the LED. Now let's take a look at some of the most common mistakes that students make when learning to use a breadboard. Here we have the demonstration circuit from the previous part of the video, with a battery, a resistor, and an LED. At first glance, everything probably looks fine, but when I turn the battery pack on, the LED doesn't light up. You won't know why unless you look closely at the breadboard. When we zoom in, you can see that one of the LED leads is actually in the wrong row. Notice how all of the connections are in row 5, except for this lead of the LED, which is in row 4. Remember that rows 4 and 5 are not electrically connected, so in order for electricity to have a complete path to flow, we have to move that LED lead over to row 5, and then the LED will light up. Every time you build a circuit, you should always double-check your wiring to make sure your connections are in the right place. Another common mistake is not firmly pushing leads or wires into the breadboard all the way. Watch what happens if I pull this jumper wire out slightly so the connection is loose. The LED will still light up intermittently, but bumping the wire or shaking the breadboard can easily make the LED go out. To make sure the connection stays secure, you have to make sure the jumper wire is pushed firmly into the breadboard on both ends. The same goes for other components like the LED itself. You can see that if I pull the LED out slightly, it might look like it's actually pushed into the breadboard, but it's actually very loose and won't stay lit. This is because the leads aren't pushed in all the way, so to make sure it stays on, you have to make sure the LED is pushed firmly into the breadboard along with the rest of the components. The next common mistake will depend on the individual components in the project you're doing. Some components have polarity, meaning the direction they are facing matters. LEDs are a great and very common example. Notice how if I grab the LED and flip it around, it doesn't stay lit. If you look closely at an LED, you'll see that the two legs are actually slightly different lengths. The longer leg is the positive side and has to be connected to the battery pack's red lead. The shorter leg is the negative side and needs to be connected to the black lead. The resistor, on the other hand, does not have a polarity associated with it, so I can flip the resistor around and the circuit will still work just fine. When using a breadboard, you'll have to decide what type of jumper wires you want to use, and there are several different types available. First are these long flexible wires that come in many different colors and are usually sold in packs of at least 10. The wires themselves are very flexible, but they have metal pins attached to their ends that make them easy to press into the breadboard. While these wires can be very convenient for simple circuits, they can get very messy with complicated circuits, and as you add more and more to a breadboard, you'll eventually get a tangled nest of wires that can be very hard to keep track of. Another option is to buy a jumper wire kit. This is a small plastic container that comes with many different colors of wire that are pre-cut to certain lengths. The ends of these wires are bent down 90 degrees, which makes them easy to press into the breadboard and keep the wire flat, which can make the circuit much neater than the longer, loopier, flexible wires. The downside of these kits is that they usually only come with 1 or 2 lengths for each color, which can make it difficult to color code your circuit. The final option is to purchase special spools of wire called hookup wire, and use a tool called a wire stripper to cut them to length and then strip off some of the insulation to make your own jumper wires. You can see here I'm just taking a spool of wire, cutting a short segment of it, then using the wire strippers to strip insulation off of each end.
Okay, guys, so yeah, so this is what I wanted to show you about the breadboards. So let me see, I'm still sharing the sound here. Okay, so any questions about breadboards? Everything pretty clear, right?
Yeah.
Okay, sounds good. So let's now maybe actually do something with our hands. Let's dive into the kits. Take out Arduino. Arduino is this guy. So we will need this guy. We will also need a blue wire, the cable, that USB cable that is connected to the computer. So open it up. Prepare everything for connection, and also in the large section of your box, there's a little cardboard box, another cardboard box with the breadboard. It looks like this. So take the breadboard out of it, and we will try to create a small circuit right now and test. Is it really works the way that we just saw, or it was all just a fairy tale?
I already have done all of that.
You already have done on it? Okay.
Yeah, my sister Anna told me that we would be doing it because she's in Waterloo right now studying engineering, so.
Oh, excellent. Excellent.
I kind of talked to her and she told me a lot.
Can you turn on your camera and show us what you've done?
Do you already have the circuit
Sure.
right now? Okay.
Well, no, I mean, I have the.
Oh,
thing.
you done it before. Okay.
No, I mean, like, I have that set up.
Oh, excellent. Okay, you will need the you will need the breadboard too now. So get the
Yeah, I'm
breadboard
getting
out.
that done right now.
Okay. So what we're going to be doing is that we will connect our breadboard in a way that is shown right now on my screen. So we're going to have plus wire connected to the 5-volt and ground to the minus wire. So every power source of a direct current, like a battery, has plus and minus terminals. And current flows from plus to minus, like water in a garden hose if you connect it to the tap. So your tap becomes plus, and then whatever your water is powering, like for example a spinner or a sprinkler is a good example. Sprinkler is something that works by using the power of water. And the same thing, electrical thing works is exactly the same way as the water pipes. And we will connect. Justin, you good? Yeah, we connect. Okay, thank you. I think Rylan keeps being kicked out and then connects back. Hey, Rylan, you good?
I couldn't follow what you said. Can you please say it again?
No, I was just talking to Rylan, and because he's keep losing connection and then connecting back. So, Dhruva, do you see the screen I'm sharing?
Yes.
Yeah, okay, so that's what we're building. So we need to have Arduino, we need to have 2 wires. We're gonna connect those wires to plus and minus, and then we're gonna create something that would do the work for us. So I would use this LED here, and I will plug it in. How do I plug it in? Let me spin it like this, like that.
So Alex is doing it on the screen. You guys are doing it on real Arduino.
Yes, yeah. You don't repeat it in Tinkercad, although you're welcome to do it if you want. I will all share with you the connection data so that you can go in. Rylan, you're good? Because I see that you've been kicked out of the meeting a few times and then rejoining. Can you hear us all?
I've been using Will's computer when I'm
You have a lot of echo. So if you're using two devices, keep the one muted at all times and the other one on mute only when you need to speak.
And it's not just muting, it's also the speaker off, right?
Okay, so I would like now this LED to light up whenever my Arduino gets power from the computer. How do I do it? I will need to connect one of the leads to the negative and the positive.
How do we connect, Alex, the Arduino to power?
We'll just use USB cable that is part of the Arduino kit, this guy.
And connect it to computer, right?
Yes. So it has two different tips, so there is no way to connect it in a wrong way. So the rectangular piece goes into your Arduino, and the flat piece goes into your computer.
Yeah, and let's go one by one and make sure actually they show us their contraption so we can see that they got that right. For those who are doing it first time, it may not be as intuitive, right?
Yeah. When we're working with circuits, it's very important to try to avoid shorting it. So for example, if you connect 5 volt to the ground directly, you're going to create condition that's called short circuit. This condition is bad for Arduino. It can result in Arduino being damaged or burnt. And in most cases, there is a short circuit protection built in the Arduino. So what you're going to end up with is that your LEDs indicating your connection is going to go off. Your Arduino go into the paralysis mode, and your computer going to stop recognizing it. So you won't be able to program anything until you resolve it. So that's why we do not connect negative directly to +5 volts, only through some device that does the work for us. And work can be anything, can be a light emitting device, can be motor that spins, can be servo that moves robotic hand, or any kind of other contraption. Can be buzzer that makes the sound. Okay.
Okay, so I think we should go one by one through everyone and see their contraption to make sure everyone's on the same page. So if anyone's done, can you guys show your breadboard, your Arduino, and the wires in between so that we can see that you set it up correctly?
I need to ask a question.
Go ahead.
I don't get the breadboard thing.
You don't have breadboard?
Huh? I have the breadboard, but it's confusing.
Okay. Well, if you look at the breadboard, it should look it should look longer than this stuff that I have on a screen.
Yeah.
But same idea. You have those rows in the middle, and these two kind of a looking rows on each side that marked with plus and minus.
But on yours, it's like all level, everything. But mine, it like all of them are like different. Like it's like the top row is all level, but there's a top row before the minus and plus top row thing.
Let me see. Okay. So yeah, you're thinking that they're misaligned, right? That's what you're saying? So
Yes.
that alignment is not important. So what's important is that you just trace the rows. So if you connect the power to the to this guy here, right, to the plus and minus, that power is going to propagate all the way through, and you're going to get all that thing as a +5 volt source, so you can connect all your kind of stuff. So if I want to connect like 20 different LEDs, I can do it. I can just continue plugging them in like this, and I'll make it for fun, different colors, and I will be able to connect them like that and bring resistor over. So if they're slightly misaligned, that's not a problem. What you need to focus on is that when you connect a device to, for example, in my case, LED connects to row 2 and row 3, that when you connect the that row to your negative, you need to make sure that it's plugged into the same row, in row 3. And if they're slightly offset here on the board, with a little bit of offset, it doesn't matter. Right?
And remember, the power doesn't flow through the gaps. If you need the power to go through the gap, you have to bring the wire, right?
Yeah. So for example, if I moved my red LED one row down, it's not going to work. I'm going to have to move this wire too. I need to take this thing and connect here. And then my resistor also, my resistor also going to have to go here like that. So to be tidy, actually, I need to move this piece here like that. You see? So it completely doesn't matter which row you can use. You can plug it into row 20, 15, 10, 11. Just make sure that the other lids that used for connecting, supplying power to it are in the same row.
Okay, and which resistor are you using, Alex?
I'm using 100 ohm. And also, guys, if you look at inside your kit, there is a plastic bag there, like this, that has a gazillion of different resistors. Resistor is a device that kind of limits the current. It's the same, for example, as if you have a garden hose again, and you like have a clamp or something that squeezes the hose. So you basically squeeze it so that from the tip you wouldn't get that super strong flow. If you want to limit, imagine you have very delicate model of a water mill that requires some water to flow onto the wheel, and it will rotate nicely and create some sort of like motion, right? And then your garden hose, once you open it up, it has such a strong flow that it destroys the entire thing. So you need to limit it somehow. So the limiting device is a resistor. So you clamp your hose a little bit so that out of the tip you get a more controlled amount of water coming out. So the same thing comes with electricity. If you eliminate this resistor and you just put a solid wire between, you're going to have this LED exploding. By the way, safety measure. We had a case, not very often, but we had one case when student connected LED directly to Arduino. So it connected two wires, one to plus and one to ground, and the resistor has exploded in his face. So please avoid that. And we cannot provide the safety glasses to you guys from here, but if you have safety glasses at home, I would recommend to use them.
It's not supposed to happen. The LED should just burn. I don't know how it happens.
Yes, yeah. In 99 out of 100 cases, the LED is just going to burn out and never come up again. But in some rare cases, it might overheat and crack.
What
resistor
were you choosing again?
You can use any. You can use 220, 330, or 100. In either case, it will work.
We will go through the theory a little later. We just want to like dive you into this, guys, so that you get you actually get to touch the Arduino and build some circuits first, so that when you hear the theory, it actually starts clicking, right?
Almost likely ask Anna.
Almost.
Okay, so what we expect from everyone now is to have the Arduino, the breadboard, grab your wires, LED, and the resistors, and connect them just as on the example on the screen, right? Yeah, I see Dhruva put his glasses. Good job.
I got a question. Where are the resistors?
They're in a plastic bag in a large compartment under the wires, maybe. So they look like this. Yeah.
Oh, okay.
And ohm sign is
omega.
Yeah.
Omega sign indicates resistivity units, which are ohms.
Can you show how ohm sign looks?
Yeah, on my screen here, you see that resistance 100, and this is a little sign omega. So that unit measures how many ohms it has. So everything has resistance. The less resistance you have, the more of electricity can flow through without losses. The more resistance you have, that means that there will be more losses to electricity when it passes through. So to make some examples, a wooden toothpick have very high resistivity, close to, I don't know, hundreds of mega ohms. So if you connect wires to it and then connect LED, there is no electricity flowing through it. So those materials called dielectric. So they include plastics, glass, stones, wood. The contrary side of it is metals. So most of the metals conduct electricity. If you take copper or aluminum or a metal steel nail or a wire, all those things conduct electricity, and you can use them as conduits for your circuits. And of course, some metals conduct electricity better than others. Some of the best ones are gold and copper. Gold is very expensive. It's used only in microchips. So if you use a computer that has microprocessor in it, probably most of the computer do, the contacts of those microprocessors are coated with gold, and to minimize losses and heat. And the next best material to conduct electricity is copper. That's what all the wiring inside your walls are made out of. So when you connect your fridge or your TV to the socket, everything behind that socket inside the wall is the copper wires that go into the distribution box in the basement. And from there, even thicker wires go outside to the transformer. And then from there, even thicker wires go to the large power distribution circuit.
So I think Ayan has a question.
Go ahead.
Yeah, I don't know why my LED is not lighting up.
LED doesn't light up?
Yeah.
Okay, so a couple of things to check.
To your computer?
Yeah, look at the LED. One of the legs is shorter than the other. We already covered it. It was briefly mentioned in the video. So shorter LED leg is supposed to connect to the ground, and the longer one connects to the positive. Also, for this kind of circuit, it completely doesn't matter how you connect your resistor. You can connect your resistor this way. You can flip it. You can flip it like this. It doesn't matter. Connect it here. Also, it doesn't matter even if it goes to the plus or minus. You can connect your resistor to the minus like this, and then you connect your plus directly to the other leg like that. It's gonna still work. So a resistor can be anywhere in the circuit as long as it limits the amount of current flowing through the LED. But what's important is that the long one connected to plus. Let me make it red in this case.
Can I go to the washroom?
Of course. You know where it is, right?
Yeah.
Are these the resistors?
Yes, those are the resistors, yes. So the ones that we need for this exercise are in a range of from 100 to 330.
And Alex, to help envision that, can you trace with your mouse how the electricity flows through the...
Yeah, so electricity, we start from 5 volt. It goes
First of all, it comes to Arduino through the USB port,
yes,
right?
exactly. We get power coming from computer to the Arduino. Then inside Arduino, it routes it to that little outlet here. From this outlet, it goes in through here. It goes to the breadboard. Then it flows through here. And then in case of our first LED, it jumps through that wire. Then it goes underground using that metal clips inside the breadboard. Then it ends up in the LED. It goes through LED, creates the job in there, then flows out of the shorter leg, comes back, goes through resistor, jumps over to the negative bus, and returns through the green wire to the ground. So that's the complete circuit. And the same thing goes for the second one, the same way. It goes to the positive, it goes all the way here, jumps through the resistor, goes to the long leg, through LED, to this guy, to the negative, and comes back to the ground. So that's how all the circuit is going to work in our Arduino projects.
Is that clear? Yeah?
Yeah. Is this correct? Check.
My, why is my LED not as bright as my brother's?
Brightness of LED depends on several factors. One is the resistor. So if your brother is using 330 resistor and you're using 100, yours is going to be brighter because more electricity going through it, because resistor has less of the influence on the circuit.
Yeah, so you're using the 1000K resistor.
Exactly. So if you're using 1000K, that means that resistor limits it quite a lot. So very little electricity left to go through the LED. That's why it's not that bright. Sometimes it's actually a good thing, meaning that if you limit it, for example, you know those LED lights that are in your household, sometimes they burn out just because too much of electricity goes through LED and they work with a lot of temperature.
For the short wires, do we use the wires like these?
Yeah, exactly. The kit comes. The kit comes with the wires that are different lengths, right?
There you go. Magic is happening.
Yeah.
Oh my God! Look at how big the light is.
Is this correct, Alex?
I'm kidding.
Is that Katerina?
Can you please?
Catherine, yes.
Let me see. It's hard to tell on a small video. It looks okay, but just make sure. Yes, yeah. Bring it even closer. Can I like zoom onto this?
Take a snapshot and
Spotlight
then.
video. Yeah, looks correct. Yeah.
Just try to plug it in and see if it lights up.
Computer.
If it doesn't light up, you know something's wrong.
Okay.
Right now, your Arduino doesn't have any power, right? So you need.
I know.
Power.
Yeah. I took the power out while I was doing it, just in case.
Okay. Yeah, that's a good safety measure. And the other thing, it's pretty simple, right? The other thing is just to make sure that the leg of the LED is connected to plus side, not to the negative side.
So guys, also, you see, I connected my LEDs different for both of them. So red one has the positive leg connected directly to positive line, and the negative goes through a resistor. On the green one, the other way around. My negative goes straight to the ground, and my positive goes through a resistor. For practical reasons, there is no difference between them. They will work exactly the same way. Okay, so that gives you an idea of how flexible it is. So you can, as long as you know what you're trying to achieve, there is a more than one way to do it.
Did it light up, Katerina?
I got it to light up.
Excellent, excellent. That means that your Arduino works, your circuit is closed, is complete, and yeah, and all of your other components work fine.
Okay, so let's go one by one. I see Ian's light, yeah, LED is up. What are you doing there? I thought you're muted, I can't hear. Yeah, good job, Ian.
Yeah, no, Ian, so yes, I am. Is it work for you?
Yeah, it worked.
Okay. Ricardo. Works?
Mine also worked.
Okay.
Hey, cool.
What?
Ricardo, I was asking, is your LED lighting up?
Yes, it's lit up.
Excellent. Good.
Yeah.
Dhruva?
Not yet. I'm putting the LED on.
Okay. Good job with the glasses, though.
Yeah.
Kranti, how are you?
I'm still working on it.
Okay.
Do you want to turn on your camera so we can help? Yeah. Okay. Yeah. Show us what you got.
How about Will and Rylan?
No, your camera went off, Francie.
Where's the?
There you go. Yeah, so it won't light up unless you actually plug the Arduino to some power source. And in our case, we're plugging it directly to computer because computer can generate that.
Okay. 1 second.
So to test it, just plug it to computer. Yeah.
Wait, what? That's what you're doing. How does that even work?
Your Arduino set does come with the battery holder, and I think one Corona battery, 9-volt battery. Yeah. So alternatively,
so you guys,
you can plug it to the battery.
For most of the time, we will be powering our circuits using computer cable because will be pushing the code to Arduino on a regular basis. So we will be needing that connection because this is not only for powering Arduino. USB also needed to program it. Okay, so we're going to need to have that connection to the computer most of the time. But once we have finished our project and we would like to take it on the road, for example, if you make something wearable that you don't want to drag your computer along with you all the time, you can power your circuit with Arduino with the battery. So the battery, there is a jack that goes into this black connection here, where the power cord is. And this way, once you program it, this program will stay in your Arduino, even if it's turned off. And then as soon as you provide power from the battery, it will come alive.
That's nice.
Yeah.
Okay, so we're waiting on Kranti, Will, Ian, and Rylan, right?
Yeah, you guys confirm that your LED is on, and then we will go further.
Mine is
Good.
on.
My LED is on.
Wait,
Juba, good job. Awesome.
my LED is on too.
Okay. Who needs help? Who still doesn't have it lit up?
Okay, Will shows the thumb up. Will, does
Yeah.
that mean yours, your LED works?
Yes. Rylan.
My LED's on.
Excellent.
Awesome.
Okay, everybody's in. Okay,
Yeah.
perfect. So
Did we hear back from Ian?
yes, yeah, Ian was the first one. He has the two devices, right? So the one in
okay.
the corner there, he's with the green light.
Okay.
Yeah, excellent.
Good
All
job,
right.
guys. Awesome.
Wait,
So-
Kranti, do you have a question?
Kranti, go ahead.
Yeah. Like, which one do I need to plug to get the LED light on?
So you can just plug it into your computer using the USB cable, and it should power up.
Alex, can you show them with your mouse
Yeah,
the
this,
USB port?
here you go, Kranti. You see this cable here?
Yeah.
The blue one, yeah. Open it up and plug in the rectangular piece into your Arduino.
Just like you would plug any other device to your computer, right? Like just like you plug your phone to the computer, same way.
Yeah, like this, Kranti. Here you go. You see? That's why.
Imagine Arduino device is your phone, and then you need to power it. You just plug it to the computer using the USB cable, right? Same thing here.
Also, guys, did you have a chance to download the Arduino IDE on your computers?
Yes.
You will need to have it to program your Arduinos. So it looks like where do I have it? Let's see. Here it is. It looks like that infinity sign with the minus and plus icon, and when you launch it, file new, it's gonna look like this. Basically, a little window with the two pre-built functions already in it once you launch it. So this is the thing that we will be using to program our computer. But at the moment, you don't have to start it yet. But by end of the day today, we will have our LED lighting up based on the program that we put in it, not just directly, right? So right now, we just covered how the circuit works, how to build a circuit, and we proved that, yes, the breadboard is functional, your Arduino is working, you get 5 volt coming out of it, we connected all the wires, everything worked. Now we would like to have some sort of logic programmed into our Arduino, and LED should be lighting based on some sort of protocol or the program that we will devise. Tinkercad has very interesting and very useful feature where you can actually code without knowing how to. So you don't need to know syntax. We will be learning syntax, of course. We will explain everything, how it actually works inside the C# code. But in here, if you click on that button here that says code, you have the boxes that are familiar to those who have done Scratch programming before. Any of you here done Scratch before?
Can you give us guys some answers in the chat box, maybe?
Yeah, there you go. So I say Dhruva, Jwad done it. Many, I think this kind of a block structure came up from MIT. The guys in there have came up with Scratch, and then a lot of people adopted it. So right now there's a App Inventor. software that is using similar idea, also coming from MIT, and the Tinkercad. So if we would like to code, we can just using those drag boxes. And after it's done, it translates it into a C# code, and we will be taking that code and putting it into Arduino. So for now, we have done just lighting up LEDs. So if we want to control it, rather than powering it with plus 5 volt, we'll need to connect our LED to one of the digital pins here that by default do not have any power comment of them. But you can program to turn them on at any time with any kind of level of power. And you can manipulate on and off states of those pins based using the program. So let's try to do that. I will just disconnect the wire from plus 5 volts, and I will connect it to, I will connect from the bottom here. I will connect from here, go around, and I will plug it into the pin number 10, for example. Boom. And I'll change the color of it to blue.
Well, do they need to get into Tinkercad now?
Yeah, if you guys would like to, I would recommend actually to go open up the browser and go into the Tinkercad. And we're gonna have to log in. I'm gonna put it in the chat. The login username would be juniotechfusion@gmail.com. And the password would be juniotech1, if I'm not mistaken. Just try that. Tim, can you log in and see if it works for you? Rather, you can also log in and try. Also, good thing with the Tinkercad is that when we create circuit, everybody in the classroom will be able to see it. So try not to mess with other people's circuits, but you are welcome to go to the teachers or instructors sketch, and I will be posting code there that you can snatch from there and use it for your project. Okay, so for now, if you create new circuit, give it your own name so that you can find it later. Actually, I can rename mine from Shiny Furren Denser to Alex. That's why you know which one not to touch.
Telling us to go on. Get on
this. Let me know if you guys found it.
I'm having trouble signing in. Do I sign in with juniotechfusion@gmail.com?
Yes.
Okay. Do I sign in with Google or?
No.
If you sign, if you sign with Google, it will ask you to create your own account, which you're welcome to do. But in this case, you won't be able to share the code.
You see the blue option, email or username. So choose that one.
The password doesn't work.
Try just Junior Tech without one. Can you log in and see, because mine is automatically pre-filled. Try to log in and see which one works for you.
Western, sign in with Google.
No, don't sign with Google.
Stop playing with this.
Actually, I want to actually give you this option. If you sign in with Google yourself, that will be your personal.
G capital.
Which one?
Junior Tech 1 password.
Capital? Okay,
yeah.
There you go. So guys, if you're welcome to have your private personal account in Tinkercad. This is good because nobody can mess with your design once you have that done, and you will keep it forever. The con for that, the minus of this situation is that you cannot ask me to troubleshoot it because I will not have access to it. If you use the Junior Tech account, I will be able to see all your designs, and I will be able to go in there and look for problems and fix it up for you.
Yeah, so for this week, everyone please use the Junior Tech account so we can actually go ahead and troubleshoot it. But after this week, we strongly encourage you to create your own login, username and password for this website, and just move all your projects there. Yeah?
I will help you out around.
Okay.
Okay, so now everyone please, tinkercad.com. The login with email or username, it's a blue option, a blue button among the options, and the email address is juniortechfusion@gmail.com, and the password is juniortech1 with capital J.
The password doesn't work.
Did you try with capital J?
But I have
Yeah,
I have to go
I
to
copied and pasted it.
From the very last line, passwords junior tech one, because the one that Alex shared, it wasn't with capital J, so that won't work.
Oh.
Yeah. So.
Good job being patient, Rylan.
You're just gonna have to make sure they're paying attention and not.
Well,
Yeah, the one that Alex shared was like lowercase j, and that's the wrong one. Junior tech is supposed to be written with capital J.
Yeah, does that look right?
I mean, the password.
Yep.
Okay.
Okay.
I accidentally logged in with Google.
You can sign out. You can click on that little icon on the right here with the kind of avatar. Let me see.
Oh wait, I can't.
It's probably on your name, Alex. Wherever it says Alex.
No, this is the name of the project.
Right.
So let me come here.
Oh, okay. So you have to be on there.
You can log out. Yeah, I already see that Ian has created his. There is somebody called Frantic Blood Altis. Guys, give your name to the designs, okay?
Yeah, give your first name so we know.
How do you change the name again?
Just double click on it. So once you open your thing, let me tinker this. In the right hand side on top, left hand side on top, there is a name. You double click on it and then you change it.
Can you give us a little quick tour through the Tinkercad? So from the
actually, once you log into Tinkercad, it will probably by default will be a 3D design environment. So let me do this.
Yeah, log out and just log in completely so we don't confuse them. Yeah.
Log out. So if you go to Tinkercad, it's gonna look like this, and I'm gonna go sign in with email and username. It has juniortechfusion@gmail.com. Next. And my password is pre-filled because it kind of remembers it.
One with capital G.
Yeah.
You signed in Google, right?
Yeah. And once you're inside, guys, there are 3D designs, circuits, code blocks, and lessons. What we're looking for is circuits.
I'm sorry. Whoever asked if he signed in with Google, no, he didn't select the Google option. He selected the email or username option. Okay. That will allow you to enter any email address there. Yeah. Okay. Go ahead, Alex.
Yeah. I go to circuits. I already see that I have Ian.
You see on the left side, there is also 3D designs. You have to be in the circuit to see the projects, right?
It went into like this 3D print, what I did with 3D printing when I went in.
Mm-hmm.
I don't think it's the right one.
No. On the left-hand side, there are 4 different options: 3D design, circuits, code blocks, and lessons. Click on circuits.
Okay.
Yeah, Tinkercad also can be used for
Tinkercad won't load
designing or sharing 3D printing designs. So we will be working only with circuits for this class.
Tinkercad is like a big platform, but their circuits
excuse me?
options pretty good.
I have a problem.
Okay.
Yeah.
Basically, Tinkercad won't load. Like, I have tinkercad.com written on my Google, and it just won't load.
You can refresh it. You can try to restart the browser or try a different browser.
Okay.
You can just try to close it and open it again and search again. Also, check your URL. Make sure you're spelling it exactly correct.
Like design.
It's Tinkercad. It's not Tinker, right? It's Tinker.
Create new circuits, right?
And Katerina, maybe share your screen so we can see what's happening.
I'm trying to refresh it. So, okay, it worked. I don't know.
Cool.
I refreshed it before that, and it didn't. I don't know. Sometimes Google likes to be funky.
Yeah, I also put the right website name in the chat box.
Oh.
Yeah.
Okay, so we see Ian, Ayan, Najwat. Who is variable input? Can you please?
That's me. That was my older one from the last class.
Right. Okay, so I have only 3 now, right? 3 projects. So we want to see the rest of the projects here.
Okay, we just named it your name.
So I'll get the bill?
No, you
I don't know how to do. Oh, circuits, finally.
Yeah, so to create a new project here, you're clicking on the green button. Alex, can you walk them through that?
Yeah, guys. Once you're in circuits, there's a green button here that says create new circuit. You click on that and you end up with the brand new blank screen and the components on the right that you can drag onto your screen and start manipulating.
Yeah, so it's drag and drop. You select your components, your Arduino board, your breadboard, your LED, your wires, your resistors, all the components on the right. You'll just literally drag and drop it and then connect them. Okay. Just like Alex did.
It's not giving me the option to like get out.
Did you click on that right little circle with the human head in it? Click on that and there is a log out option. You can, if you logged in with your Google.
No, wait, Katya, can you share your screen so we can see what you're doing there?
Is it Katya who asked or is it Ricardo?
Yeah, one sec. I just have to.
I think it was Ricardo had trouble.
Ricardo? Oh, okay. So, guys, if you need help, we need to see your screen. And Alex, can you allow screen sharing? Because I think right now they can't share the screen.
Let me see.
Oh, I'm using my own account.
How do you spin it well?
How do you enable screen sharing?
Spin what? God, the thing. Can you ask him?
Yeah.
I don't know.
I have 2 meetings I'm supposed to be in right now, and I just walked away because I was like, I can't.
I think I have to stop sharing myself in order to enable it.
Yeah.
Yes.
Do you guys want to go into separate breakout room and troubleshoot them?
Who's having the problem?
Can you ask him how to do it? Spin it?
Okay.
I think.
So can you give us, can you type help in the chat box if you need help connected to Tinkercad and creating your project?
Okay.
Make sure we can facilitate.
How do you like take the?
Ian, you have one of the devices creating feedback loop.
Guys, in order to avoid that, just
one of the devices keep the speaker
turn off the
off.
speaker, not just mute it, but like.
How do you get it to spin?
Not Ian, I think it's Rylan and Will.
No, I think it's Ian. Ian has the.
How do you get the things?
He has it on his computer, but then he has another desk device that is having microphone off. So,
how do you get the pieces to spin?
Oh, okay. So let me show you. Tinker this. So if you bring in a device to the, like I bring this capacitor and I want it to spin, you have it selected. And on the left side, there's a little triangle with an arrow. You click on that, and that will make it spin. Right? This way you can like connect it to things. For example, it's at the wrong angle right now. I cannot plug it in. So I need to spin it until it's flat, and then you can plug it. Got it? Okay, I think I'm gonna go ahead because we kind of are running later already. And if anybody needs help with the Tinkercad for any reason, raise your hand. I'm gonna assign you instructor, put you in the separate room, and you guys gonna get help. Okay, because otherwise we're gonna be way slower than we only have 5 days, and I have a lot of material to cover. So I would like to show you how the code works now. And we will try to program this red LED to illuminate at a certain interval rather than just being plugged in all the time. So we'll start with that, and then we will introduce logic when we will be reading actually the sensor, and based on the sensor readings, we will turn it on. So for example, a good example is like Christmas lights. We would only want the Christmas lights to come on when there is a dark outside, because it doesn't make sense to light up Christmas lights during the day, right? So we're gonna connect the light sensor to the Arduino, and light sensor gonna tell our circuit when the darkness have come, right? So you're gonna set up certain threshold for the brightness, and when it's gonna go dark, your lights come on automatically. But that would be step number 2. Step number 1, we just show you how to make programmatically that pin that the LED is connected to, pin 10, go hot. Okay, I'm gonna go to codes, and I'm in here gonna delete all that thing here, that whatever was pre-built, and I'm gonna work with the pins, with the blocks on the left side of that panel. And you see that, how do you delete things?
Yes.
So if I have a block in here, I just take it and drag it into the bin.
No, like from the
this thing is, so if I have a device here that I don't need anymore, you just select it and click delete on your keyboard and it will go off. I think you can also right click it. No, right clicking doesn't work. So delete on the keyboard.
Oh.
Try it.
Okay, so if you have like,
there's also a little trash can symbol in the top left. So if you like click on something and then the trash.
Oh yeah, exactly. So that's another option. So if my LED is here and I don't like it anymore, right? I plug this button in here. I don't like it. I can click on that little trash can and we'll delete it.
Okay, Alex, Ricardo is asking for help. Can you actually create the breakout room and send team there? So if you guys, if anyone needs help, just type help in the chat box and we'll take care of it, okay?
Just have to slow down.
Okay, who needs help?
Ricardo.
Ricardo.
Okay, Ricardo, I will put your desktop on it. I will keep your iPad in here. Is that okay?
Yeah.
Or I can invite you both for iPad and the other one. And once you get notification, click accept, and you will jump into separate room with Tim. Tim will troubleshoot your problem, okay?
How do you take the... How do you take the thing? How do you take it? How do you change the color of the wire?
Very easy. If you select a wire, this thing pops up here that says wire color, and then you select and change it to yellow, for example. Super easy. Got it? Excellent. Okay, back to coding. This is our code. So if I would like to turn that LED on, I would like to make that pin that it's connected on hot. Or basically, we're going to supply 5 volt to that pin, which by default is not. So how do we do it? There is a block in here that we drag onto the screen that says set pin number to high. All you need to do is just select the pin number, which is pin number 10, and we put it to high.
Alex?
Yeah?
Could you add his computer too? I don't think his iPad has.
I added both.
He
just needs to select join on the computer as well. Ricardo, I've added you to breakout room there. You can go to breakout room and join it.
Yeah, except the join from the desk.
He's gone now.
No, his Ian desk is still here.
No. Ricardo is both in team in the breakout.
Oh, okay. Okay, good.
Yeah. So this is pretty easy, right? Set pin 10 to high. So in this case, if we run this code, start simulation, you see both of our LEDs lighting up because the cable, the wire that connects the plus 5 volt level to the both of LEDs connected to pin 10, and our pin 10 has been set to high. So it's not very impressive program because it doesn't make any difference from what we've done before. Before we were just plugging it directly to plus 5 volts, and this thing does exactly the same. So let's make something funner. We can switch to control module of the things, and we can do a little bit of a delay. We're gonna plug it in here, and I'm gonna keep it at 1 second. And then when 1 second elapses, I will go to set pin again. And in this case, we're gonna select pin 10, and I will gonna set it to low instead. And since this code is executed over and over again in a continuous loop that runs forever, I would want to have another delay.
Way behind.
You have your mic on.
I don't.
Okay, so right now, let me test the code. Let me run this thing and see what happens. Do you see how LEDs come on and then go off?
Mm-hmm.
So these LEDs right now work based on the program that we have just created. And that program is very simple. It makes the pin high, it waits for 1 second, then it makes the same pin low again, meaning that no electricity goes to that pin, it cuts electricity. And then it waits again for 1 second and starts all over again. So this thing repeats over and over again, and that causes the LED to come on for 1 second and then go off for 1 second and then come on again and go forever. Is it clear?
Similar to Scratch, everything is color coded. So if you're wondering where the blue boxes came from, the puzzle pieces, they're obviously from output because it's also blue, right? Yeah.
So since I'm happy with the result and everything seems to be working, I want to put this code in our Arduino and see how it actually going to work in the real life. There are two methods that you can do. One method is just click this download button, and it's going to download the sketch straight into your computer, which you can open then and put it into your Arduino. And second method is you can actually switch the code from blocks to the to actual code. Let me see. Yeah.
I can't really get that. It's really hard. What you're doing there. I kept trying and I couldn't do it.
You mean this the creation of the program?
Yes. No, like the programming, the lights go on and off thing.
Oh, well, basically what I did is I dragged 4 blocks onto the screen. So let me just throw it out again and pretend that I haven't done anything yet. So what I did is once the circuit is completed,
I'm sorry, can you go to his project and actually show it to him on his project?
Sure.
So Alex?
Yeah?
I'm not sure my boys are understanding. Are you expecting them to follow along and build what you're building? Or are you just expecting them to watch what you're doing right now?
I would like them to watch what I'm doing right now and then know how it's done. So the best way probably to do it is quickly whip it up on the Tinkercad as well. So let me actually show you him on his own design.
Okay, so can I ask you just for their knowledge, when you're wanting them to just follow along, tell them that? And when
sure,
you want
absolutely. Here is the wheels, right? Let's go tinker this. Here is the wheels design. So Will, if you don't mind, I will tinker with your design a little bit. So I will flip this thing like that, and I will flip your the breadboard also vertically so that you could see the rows and letters properly aligned. Okay. I will disconnect this wire, and what we need to do is we need to connect ground to the negative pin here. Do you want to do it yourself, or you want me to do it for you?
You can do it.
Okay. So let me connect the ground here. Like this, and then our positive part on the breadboard we will connect to pin number 10 like this. Okay, now we need LED connected somehow, so that we bring LED over, we flip it on the side like this, and we plug it anywhere in the breadboard you like. So you can go higher, lower, in the middle, we can plug it right here, it doesn't matter. You just note which rows are engaged for the legs. Now it's number 14 and number 15. So we need to use resistor as well we were covering. So one way of doing it is connecting one of the legs. Short one goes to the negative, and I will use resistor here, flip it like that, and plug it into the positive like that. So done. So this is our circuit. To make it pretty, if you'd like, you can make the color change for the wires so that it will be more intuitive. Our power wire is going to be red, and our ground wire will be green. And this one is green as well because we put it for the ground. And the resistor is connected to the plus. I will change the resistor from kilo ohms to ohms, and I put it 100. Okay, now it's time for code. So if I go to the code blocks here, we already have something pre-built, so I'm just gonna dispose it all off. And instead of that, we're gonna use this block here, set pin to high. And which pin did we use for our circuit? Will, number.
Number what?
What the pin number did we use on Arduino to connect to our circuit? It's right here.
I can't see anything.
You can't see anything? Can you see my screen? Can you see your own screen?
Go back, honey.
I'm on my thing, but
There you go.
Will, do you see?
10?
10, exactly, yes. So in here in our program, we want to select the pin with the same number that we actually use. So I'm going to use the pin 10, and we're going to set it to high. High meaning that you make that pin, you connect it to electricity inside the Arduino, okay? So when this command is executed, your pin becomes the same as the +5 volt in here. So you're going to have +5 volts on this pin. So in this case, what we also did, we put a timer, we put a delay in here, and we connect one more block that puts the same pin number 10, but in this case, not too high, but make it low. And we go to control and we put another wait block. And that's all. So now if you start this thing, let me zoom out, you see your LED is successfully blinking with the interval of 1 second.
How do you get it to blink?
Alex, can you make the code bigger? Can you like zoom in on the code or something?
Let me see.
At the bottom right, there's like a magnifying glass. Yeah, there you go. Okay. Also, guys, so high and low, this is essentially just saying on and off. Okay, so high is like power going to the LED, and low is just no power. All right, it's just fancy wording for on off. All right, and then the
There are
wait.
two ways to follow Alex. One, you can actually spend time building this schematics, or if you already have it done on your Arduino, because that's ultimate goal, you forget about the schematics and just build the code and push the code to Arduino and see if it works there, right? So, so it's up to you guys if you want to follow the schematics. We do suggest you do, but if you find yourself struggling with that, with the Tinkercad, so just focus on the code.
I don't know what you're talking about.
What did he do?
I don't know. Stop asking me.
Anybody still having trouble?
Yes, actually.
That's Katerina?
Yeah. So basically, I just keep on trying to. Well, first of all, I tried for my tablet. I'm just saying that I'm a little behind.
Let me see, Katerina, this is your design, right? So I will go into your design right now.
Yeah, it's because it's really hard for my tablet. It doesn't listen.
Yeah, but you guys already all have it set up on your actual physical Arduino, right? So
I don't know how to help him. That's the problem.
You don't have what? Sorry?
I'm trying.
Will, is that you talking?
Yeah, so Katerina, if you have trouble with the Tinkercad, you don't have to use it. It's just good to know that this is such a convenient prototyping tool. So I will do it for you as well. But you just basically, you repeat this thing in actual wires and with your actual board, okay? So just go into your kit, pull it out, connect your breadboard to pin number 10. Try to maybe keep the wires different by color so that will be easier for you to troubleshoot. Okay, and then we will connect one of these LEDs in here.
I'm trying to think.
I need help.
Okay, who's that?
Rylan.
Rylan?
Yeah.
Explain what you need help with.
I know how to get it to blink, the flashlight.
On the Reality or in the Tinkercad?
Tinkercad.
In Tinkercad, well, are you in the code window?
Yeah.
Okay, so once you have built your program, and the program should look like this. Let me do this.
Yeah, it looks like that.
It looks like that. Make sure that the pin number selected here is exactly the same as you use in your schematic. So if your schematic uses pin 10, this is the number that you should use here for your high and your low. And once this thing works, once this thing put together, you need to test it. And to test it, you need to click the Start Simulation button. So once you click on that, then your code starts working, your circuit starts simulating it. and that's how your LED is supposed to go on and off.
Rylan, so right now you have this thing here saying set built-in LED to high and low. So you, instead of those, you need to be using this set pin, not the set built-in.
Yeah, built-in LED is this little guy here. And this guy also can be manipulated, but it's not as much fun, right? It's just already pre-built.
I changed your code a little bit, all right? And I said set pin 10 to high. Can you replace the second one that says set built-in LED to low instead with a set pin 10 to low?
I'm kind of getting confused with all the talking because I can't go as fast as I can. I'm trying to figure out what you're first saying, and I can't get it all out. I can't.
Okay, let's start again then. So are you looking at your code right now?
Yes.
Okay. Do you see how okay, can you use a little read out the code to me, the blocks?
Actually, I can just look at his code directly.
No, I'm looking at his code right now.
Yeah, he used the wrong block. Alex, yes, just pull around.
What?
Okay, so yeah, Rylan, can you read out your 4 blocks to me? What do they say right now?
Can you read it out?
No, they're not really looking because they're helping Rylan right now.
Okay.
They're doing nothing.
You have to go in here.
Okay.
He's asking you to read out what you have for your code.
I'm looking right now. Actually, I'm sharing on the screen. Everybody can see your code right now, Rylan. So I see that you have your all blocks in place, but I see one mistake. So can you point out and tell me what that mistake is?
One of these cords is in the wrong place.
No. Wires are all properly connected. Everything is good.
It's only in the code right now.
Oh, no, actually, there's a problem here. No, there's a problem. So circuit is all correct. In the code, let's go one by one. You set the pin 10 to high, then you wait for 1 second, and then you put your built-in LED to low, and then you wait for 1 second. So basically, what that program is going to do is it's going to turn it on once and never turn it back off again, because you don't tell the pin 10 to go off. You're telling something else to go off. You're saying that built-in LED to go off. So this block is not correct one here. So if I run your code right now, it's going to start on and never turn off. You see your LED is always blinking because all we see in the program is set pin 10 to high. There is no other line in the program that tells set pin 10 to low anymore, because this thing here sets to low built-in LED, which is this guy here inside your Arduino. So in order to fix it, I'll stop simulation. You're gonna have to delete this block in here, this blue one here.
You use the wrong puzzle piece.
And
right?
you put this guy in here, which sets pin 10 to low.
Okay.
And you put an Arduino. Is that clear, Ryan?
Alex,
Yeah.
can you go through that again? Because his zoom on his screen was off and he couldn't see what you were doing with the code.
Okay.
On
So
the
what I
side?
did, what I did is I removed that blue block that was wrong inside the program, and I replaced it with the correct one. Correct one is this one: set pin with the number to some state. There are 2 states, high and low, and we need low. And there are several options for the pin, and we need pin number 10 because that's the one that is used in your program. And then we'll wait for a second. So now if we run this program, start simulation, your blue LEDs start happily blinking.
So basically, Rylan, you use the wrong puzzle piece. You use the first blue piece, whereas Alex using the second one, set pin, right? So that was your mistake.
I never put anything in there. I just ended up like that.
Yeah, exactly. That's because when you first start whatever design you do, you have that blink thing with the LED. So you need to get rid of it. Whatever you have, you just, Do you want to do it yourself now, or you want to keep it like this? I've just actually edited your program here.
You want to go back into the other one and try?
Yeah.
Okay, you got to go into this window.
Yeah, so basically I will delete everything now on your screen here, and you do your own thing. Okay. So we're using blue area code and yellow area code. Blue area code contains the pin controls, and yellow area code contains the loops, delays, and all that kind of features, right, that you can use in your program.
Alex, can you bring up your code again so he can follow along with that?
Yeah, I'm gonna go back to my code. Where is Alex? Here it is. And I click on a code, and here it is. So set pin.
There.
Delay. Everybody now on the same page, or somebody's still struggling?
Guys, use the chat box if you need help. Just type help like Ricardo did. So we can take you to another room and actually troubleshoot your problem there, right?
Okay, I think William needs some help. He's just speaking to Ron's computer.
Okay, so William, what kind of help you need?
You gotta just leave it on this one, William.
Oh, okay. Yeah, guys, if you're using two devices, keep speaker on one off, because otherwise you're multiplying the signal.
Yeah, you'll still hear us from another device, but it's not just muting. You have to like turn off the speaker on the second device off.
Why, when I start the simulation, it doesn't work?
Okay, let's go to, can you open William's code?
Yeah. Where is Williams? Will. That's the one.
Papa. Ta-da.
Okay, so your ground is minus and your plus 10 is plus. Tink, tink. And minus to the short leg, and plus is to this leg. And let me see your code. Because you're still stuck with the you're still stuck with the default code in here. If I run your code here, do you see that little thing here? Sorry, I need to change this below. If I start simulation, you see that little orange thing here? This is the thing that you're controlling, but you have like super long delay. If I change this thing to 1. Okay, there you go. Will, do you see?
The same issue. He said built-in LED.
Exactly. So Will, you're controlling this little thing here on Arduino with the L letter on it. You see that orange light that comes on and off? That's the one that you're controlling. If you really want to control your big one outside that is connected to pin 10, you need to replace the blue boxes that you currently have with this guy. Do you see it? Do you see on my screen?
Which one?
This
I
one.
can't see it very clearly.
You cannot?
I can't.
How about if I make it like really large? Maybe it's my fault here. Is it better now?
Yeah.
Is it better, Will? Can you see it?
Yes, I see it.
Okay, so you see these blue ones that you currently have, they actually controlling built-in LED. And that's not what we want to play with. I want to delete that guy. And I will delete that guy too. And I will use this one instead, like that. And I will bring another one just like it, plug it like this. So now we're setting pin 10 to high, and then we're setting pin 10 to low. There you go. Now I'm gonna make it smaller again. Is it clear, Will?
Yes, but I can't figure out how to move the block things. They just stick
you drag it from here and you bring it into the field, like what I'm doing right now.
No, they're just sticking together.
Oh, yeah, if you want to move them together, you need to go from the bottom. So you can disconnect one here, one there, like that.
Oh.
Okay, so if you grab it by the top, you're moving the entire assembly. So if I take it like this and connect it together, and then I grab it from the top, it goes together. So in order to move them separately, you need to take it from the bottom. Works?
Yes.
Okay, so right now this code's gonna work. So if I'm to minimize it and start your simulation, your LEDs start coming on and off.
Excuse me?
Yeah.
How do you like make it do the code in real life?
Oh, real life. Now, thankfully, we are at the stage where I think everybody's on board, and we're gonna do it now. So let me switch back to my circuit. Where is Alex? Here is Alex, and we can do in two different ways. So where's my code? Here's my code. So you see, I can either click this button here and it will download the code. Then you can open it up in Arduino and you push it in. Or you can switch from box to text. You cannot go back after, word of caution. Then copy it from here and put it into your Arduino IDE. So I can do this because it's kind of more, obvious.
How do you put it in the Arduino IDE?
You can copy this thing like that, select it, right click, copy, and then go to your Arduino IDE, which is this window.
Oh.
Select it all and you paste it in it. And that's the code that we will run.
Okay.
Yeah? So a couple of things, guys.
That's what I'll do.
Yeah, a couple of things that you need to know before you push the code. So how to push the code into your Arduino is this round button with the arrow in it. It says upload. Once you click on it, if your Arduino is connected to your computer, you're going to upload the code to it, and it's going to run it right away. Usually, though, when you connect the Arduino, it might not be detected from the scratch, so you need to just check something. You can go to Tools and select the port, and then if Arduino is connected to a port, it's going to appear there. So let me actually do the same thing. I will plug the Arduino to my computer so I could demonstrate.
In the meantime, I want to check if everyone has their Arduino IDE set up.
I can go in here.
Assumption that everyone
and here's.
I don't.
Who doesn't?
Will doesn't. Okay. Will doesn't.
Will doesn't have it. Will, are you using computer or iPad right now?
I'm using a computer.
Computer. So yeah, I've sent email earlier, so everybody should have downloaded it. If you don't have if you don't have it right now, you need to open up your browser and go to Arduino. Click on that. Sorry, Arduino. No sense, just Arduino, and you will have Google returning you the link of main page of the project from where you can download the software. You can click here, software, downloads, and you can get the Arduino IDE for Windows. Or if you're using Mac OS, if you're using Mac, you can download it from that.
Oh, I have the Arduino editor.
Yeah, that's good. So I will share with Will here. I will send him a link to the. So in chat window here in Zoom, you can click on that link that I've just sent. And then if you, depending on your operating system and your computer, if you're using Windows, you download Windows installer. If you use Mac, you download Mac OS installer. And the chances that you're running Linux is very small.
I have another question.
Okay, Katerina.
I have the code, but what do I do if I want to stop it?
Oh, you cannot stop it. That's the thing. So once this code is running, it's going to run forever until you cut power to Arduino. You just need to unplug it from your computer. That will stop it. If you want to stop it like entirely, you're going to have to program it into your code so that there is some interruption that can make it stop. Okay?
How do you do that exactly?
Okay, well, there are a couple of ways. How do you want it to stop? After a certain number of blinks?
What?
Well, you need to decide how do you want to stop it. Would you like to stop it with a button? Would you like to stop it with it's just gonna expire after a certain time, or it will be some other output that will dictate?
Yeah. What about a loop that goes like 10 times and then stops?
Yeah, we can do that. Would you like to let me actually go back to our let's see if I can go blocks. Here are my blocks.
Okay, Alex, they all watch it now. Can you lead them step by step now? So I think they're confused.
Actually, yeah, it's better actually to make sure that everybody's on the same page before we go into more advanced stuff.
I still don't know how to get the right code thing. It's not what you. It's like the video setup. Put your setup code here to run once. Video loop. Put your main code here to run.
Really struggling with Arduino IDE.
Хорошо. Нет.
Tim, do you want to take somebody and help him out?
Первая программа, которая чего-то делает не в компьютере.
Yeah, Will needs
I
help.
think Will needs help. If you'd like, I can set you up with Will in a separate room. You will help him with the share screen to set up everything.
For the IDE, yeah, sure.
Yeah. So let me do.
Okay. Does everyone else have the Arduino IDE?
Will, when you get notification, please accept it, and Tim will join as well to the breakout room, and he will help you directly how to set up everything.
And guys, don't be afraid to ask for help, right? Okay.
Провод, иди сюда.
Okay, so we accepted that, Tim.
There you go. Who else needs trouble?
Did you
has
send
trouble
Tim also to that same
putting
room?
the code into the Arduino?
Alex, Tim. Okay, there you go.
Ian.
Okay, so I went through everyone's code. Pretty much everyone's using default code, so no one replaced the set built-in LED with the set pin. So in that case, I suggest you guys go to Alex's project and actually download his code to your Arduino instead. Or go back to your code and actually change that. So Alex, maybe we can take them step back.
No, actually, the even cheaper solution would be if I'm just take the code and put it in a chat window.
Okay.
I will share it with everyone. You can take this code from your chat window and put it into your Arduino IDE, and then you upload it to your board. And Kranti asks, how do you log in? Log in to where? To Tinkercad? Yeah, to Tinkercad, we log in using this. Let me see. Once you go to Tinkercad, the username would be juniotechfusion@gmail.com, and username is juniotech1, like this. So Kranti, you can use this once to log in, and then you will see everybody's projects, including yours.
We have 10 minutes left. We can probably go about 5 minutes past the clock, but we might continue next class. But we want to make sure that everybody is on the same page. Obviously, we're not going to move on.
By the end of the day, we'll want to have everybody have blinking working circuit with blinking LED in front of them.
Mm-hmm. So let's go one by one. Ian, how are you doing?
I'm kind of stuck on getting the actual thing to work.
Mm-hmm. Okay, so you're at the stage where you already created the code, you uploaded it to Arduino, have you?
Yeah.
Okay, so can you show us your code? Alex, can you allow him to
screen share? But I can't.
But they have access to this, right?
Yeah, go ahead.
Yeah. So it's there.
Can you please share your screen, Ian?
I can't share my screen because it's on the desktop and this thing's on the phone. So
yeah, that's why we recommend logging in with the same device.
Share screen. So I can't share because
that makes sense. You have to be Zoom and your Arduino IDE has to be on the same device. So
no, it's okay. It was the participant sharing was turned off. It's turned on now. Try again.
No, he's on 2 devices now.
Yeah, but he can still share the screen from his desktop.
But if he's on his phone, oh, there you go.
So it's right here. And
okay, I see the problem why it doesn't work. Let me take control. Approve. Okay. Do you see the problem here? You have pasted the loop file with all your blinkage here, and you have another loop that you, the program only supposed to have one loop, not two. So you're supposed to get rid of this guy here.
Oh, okay.
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 Also, digital high. Also, you have forgot one thing. You need to put inside here, you didn't copy from there, you need to put the pin mode command and your pin 10, you need to designate it as output.
Okay, so Alex actually sent the code in the chat box. At this moment, we don't expect you to understand what anything there means. Just copy paste it to make your life work, okay?
Okay, thank you.
So it's uploading right now, and your Arduino is connected to COM7. So click there. It's compiling sketch, uploading, and it's done uploading. So you're now supposed to have it blinking if you have assembled your board. Is it blinking?
Yeah, it's blinking.
Terrific. Okay, I'm stop sharing and go to next one who have trouble.
Yep. So who wants to go next? Who is ready to push the code to Arduino? Katerina, how are you doing?
I already done it, and I've also done where I put it in a loop and it only does it for 10 times and then it stops. So now mine stopped even though it has power.
You're a genius.
Good job. Okay, who else? I am. How are you doing?
This one?
I am. Can you unmute your mic, please?
File.
Oh, I'm doing good. I got the code uploaded.
Excellent.
And your LED is blinking, right?
Let's see.
So it should start blinking as soon as you uploaded it, right? So if it's not blinking, there might be some problem with the code. And again, Alex, did you copy paste the code in the chat? Yeah. So all you need is just to copy paste that code from Alex into the Arduino IDE. Check, make sure the COM is set correctly. That's a trick that everyone actually keeps forgetting. And Alex, I don't think.
Yeah, guys, when you're pasting the code, please make sure that you don't keep the whatever was in your window. So whenever you start new project, so if I start new project right now, I'm gonna have this already pre-filled for my convenience. I have this void set up and void loop. You're supposed to delete all that and replace it with the code that I have shared. So if you take, for example, the code that I've shared in my chat window, like this code, and you take it here and you paste it underneath, you're going to create conflicting situation when your Arduino is not going to know what is expected of it because you have two setup functions and two loop functions. You need to delete everything that was in there and only leave the stuff that I'm sharing. So we have setup function only once, and we have loop function also only once.
And again, at this point, we don't expect you to understand this. Just copy paste the code. And Alex, can you show, actually copy paste it from the chat, not from your program?
Yeah, no, of course I can do that, but it won't share
So
because my chat window is in a separate. So let's go to chat. I don't know if you can see it. Here is the chat window.
So yeah, I see. Because it's in Zoom, they cannot see it, right?
Yeah, I don't know if you see this thing or not. So Kranti is asking, like, do you press sign in or something else? Yes, when you go to the Tinkercad, you select sign in, and then it asks you several options. How do you want to sign in? So you select one with username, password.
Okay, for guys, for those of you who actually made it work and it's blinking, this is pretty much it for today. So you can sign off. For the rest of you, stay online and we'll troubleshoot your problems, okay?
Mine just started blinking.
I have a question.
Go ahead.
Can we like disassemble our thing now, or do we need to keep it for next lesson?
You can disassemble. It's pretty simple, and it's not going to take a long time to put it back together. Next class, we're going to build on top of this. So we're going to add some more logic. We're going to have some ifs. We're going to go through loops and conditions. And yes, we're going to be using LEDs as well, but it's going to very quickly. once you've done it once, it will be much faster next time. How you're going to be putting it together?
I've already done it about 10 times, so.
Yeah, more you do it, better you get at it, more clicks actually, right? So, okay, so Katerina, Ian, who else said? Ayan, you said you guys are okay, everything's blinking. Dhruva, you done it?
Yeah, I did it.
Guys, if your project worked, then you can disconnect
you can sign off,
and have the rest of the day for yourself, whatever you have planned. We are at 12 o'clock right now. If you're still needing help, please stay back and we will try to help.
Yeah. Okay.
All right. Bye-bye.
Bye.
Bye, Katerina. Bye-bye, Ian. Yeah. Bye-bye, Dhruva, and bye, Ayan. Right?
No, I isn't blinking.
Okay. So Ricardo, let's take care of you now. So can you share your screen, please?
Wait.
Not from iPad, but from the computer.
Yeah, wait. No, man.
Are you sharing, Ricardo? Click on screen share and then select whatever program or window that you want to share, whatever your code is running.
Yeah, I clicked.
Oh, here you go. Ground is on, plus is on 10th. You see your green wire on your LED is connected to the same power line as your resistor. They're supposed to connect to different ones. Yeah, you need to connect this wire to the minus. Just delete the entire wire and make a new one.
No, but wait, check his code because he said his.
No, his schematic is wrong.
No, but on his Arduino, he could actually light up his LED, right? Earlier.
Yeah, just select that wire and now take that right side and pull it further right. Yeah, that's how it is supposed to be. And now click start simulation, see if it works.
And Alex, someone's waiting on the Zoom. Can you see if someone needs to connect back?
What do you mean waiting for Zoom? Participants, you mean?
Yeah.
I don't.
No.
Nobody's waiting.
Got an email about that.
Maybe
I don't think the issue was his schematics. I think I don't see his IDE though. Is it him sharing the screen? Yeah.
Yeah, that's him. Yes. Yeah. No, his schematic is correct. Can you go to your code and show us? Stop simulation and then go to code. Yeah, go to code. You see your pin number is number 1. You need to put it to pin number 10. Set pin, select to 10. Scroll with your mouse, maybe you can, yeah, select 10.
What?
No, you can drag, drag it higher and then click on that, select pin number 10. And on the top one as well. Now on the middle one, when it says set pin to high, you make it low, not high. Yeah, there you go. And now you click start simulation, it's gonna be blinking. It's gonna stay on for a second, and it's gonna stay off for 2 seconds because
now he needs to push his code to the actual physical Arduino, right?
Yeah, exactly. So now you just need to get this code over. So what you can do is you can click on the download button.
Export? Oh, download, yeah. No, oops.
No, not this.
No, not export.
Yeah, this arrow. Yeah, this guy. Click on that.
So first I have to delete this.
You don't have to delete.
No, now you need to push that to Arduino, and there is a button that with arrow. No, go left, further to the left. Yeah, that button there. Mm-hmm. Did you click that?
Yeah, he downloaded. Now click on that Ricardo1.ino that has been downloaded. Click on that, it will open it.
Yeah, at the bottom of the screen.
Mm-hmm.
At the very bottom left.
On the bottom left, yeah, this one. No. Go down, down. Left.
You see it says Ricardo1.ino at the bottom of the screen? Not in the, yeah.
No.
Move to the left.
I don't see his mouse. Let me do this. I will request remote control. I'll show you. Can you approve remote control for me? Okay. So when you click download, you see this thing here?
Yeah.
That's your file that you have just downloaded. So if I open it up, it's supposed to open up in the Arduino. I don't see it because you only share with me the window. I don't see your Arduino thing. But when your Arduino thing pops up, there's supposed to be code in it, and then you can upload it into your board.
Yeah, so wait. I have my Arduino thing right here.
Can I just stop sharing? And can you share again, but this time you share the whole desktop. Don't share just one window. Share entire desktop so I could see it. There you go. So it says needs to be inside a sketch. You click OK. Yeah, that's no problem. Let me actually get remote control again. Request remote control. Yeah, excellent. So click OK. Yeah, here you go. Save. Sure. I'm going to call it Blinker. Blinker. Save it. There it is. OK. There you go. So now this code, if I press this button, it's supposed to go and put it into your Arduino. Let me just double check if your port is connected. Is your Arduino plugged into your computer?
Yes, it is.
Yes, it is.
Yes.
There's Arduino Uno. I don't see it here though. I see Arduino Uno, but your port. Can you unplug it and plug it back?
There.
Plug it back.
Oh,
okay.
Yes.
To port.
This is 10. Should this be 10?
Mm.
So then we can be on pin 10, right?
Let's see if I can actually compiling sketch. Uploading. Serial port not selected. Let me actually close this and open it again because the Arduino doesn't see the port for some reason.
Look right. There. Yes.
You got it?
Right? Did you get that? It was just when you had the wrong pin. Because it was sending it to pin 13 instead of pin 10.
The pin 10 is where the light's setting?
Did you catch that?
Mm-hmm.
Yeah.
So the light's on pin 10?
Yeah. Well, you know, the connection here is on pin 10.
Okay.
So you good now?
Mm-hmm.
Yeah, I think they're just helping the kids.
Where is Arduino? Arduino.
Okay, so are you guys done?
Yeah, we're pretty much done, yes.
If the physical actual Arduino
if you have a blink, then yes.
Yeah, then we're
Okay,
done.
they both got their lights flashing.
Perfect.
Awesome.
Do you have any other questions?
Do you have any questions before we sign off?
Again, this video recording, the link will actually upload it and send the link to parents so he can actually go back and rewatch the entire thing.
Okay. You good, boys?
Yeah.
Thank you.
Yeah.
Thank you. See you tomorrow.
Leave.
This. You have 2 Arduinos. Okay, this one is opening. Okay. And where is
Okay,
that?
and I called Crunchy's parents and asked her to come back in because I think she also had problems, but she signed off.
Okay.
So Rylan is still here, so I'm assuming Rylan still needs help too. Oh, he signed off. I guess he's good then.
Let's see, tools. Yeah, for some reason, this Arduino doesn't see the serial port. Do you have another?
Well, is it even on? Is it connected?
He says yes. Ricardo, is your Arduino connected?
Is your Arduino connected through USB port to your computer?
Yes, it is.
Yes, it is.
But if you go to tools, it only has some Bluetooth incoming port. It doesn't.
Can you unplug it and plug it back again?
Is there a different USB port that you can use on the other side of a computer, maybe? You use iMac?
Huh?
You're using iMac, right?
No.
What do you use? Is it laptop?
Yeah. No, wait.
You see in here, for some reason, it doesn't get detected for some reason. Are there lights coming up on your board when you plug it in?
Yes, it is.
So lights are on, but it's not recognized. And if you try to upload it, it's going to complain that the serial is not existing. Okay, I have UPS. Right, can you open up? Yeah. Is that the only computer in the house that you can use? Do you have any other laptops that you can borrow?
If my mom's not working, maybe my mom's.
Yeah.
Yeah.
Well, I can't really tell right now why it's not visible. Let's quit it in.
Wait, or I can use my family computer.
Maybe we should do that. Yeah, maybe we can try a different computer because I don't. My card needs to be inside. Okay. Yeah, it only has some weird like Bluetooth incoming port. Let me Google it. Maybe we can find it. I will stop recording.